of this explanation. Part 3, 9 questions. Question from number 17 through number 25. All right, so number 17. In the MIPS architecture, is it possible that the RT field of some I-type instructions is not used for some special cases? We have 3 different cases, right? Can you find one case that we do not use the RT field? So that's simple. Yeah. If you can find, yeah, right? So just check those 3 cases. Yeah. Number 18, in the MIPS architecture, does a branch instruction have the destination field? All right, destination field. Yeah. In my example, so I use target. So remember, so B, E, Z, so not, sorry, EQZ, right? Not equal. B, branch, equal to 0. B, E, Q, Z, instruction name, you know, R1 target, right? Okay. Do not confuse this to the destination field, because if you look at our instruction part, this corresponds to offset. Offset. So you know the meaning of the offset. PC relative offset number. Yeah. So look at that. And the destination field. So not destination, right? Because destination, you can generate the destination indirectly. But destination field, you need to have specific number of bits used to give you the destination information directly. So that's the meaning of the destination field. Yeah. Yeah. Try to separate those 2 cases. Yeah. All right. Number 19, all the floating point registers, FPRs, can store the value of variables. Yeah. So here the background is, remember, R0, it cannot store value of variable, right? Yeah, because it can only store the constant, has the constant 0 value. You can never change it. Yeah. So here, this statement, try to use the FPRs, you know, try to do the analogy on FPRs. Then you check if it is true or false. All right, so next question, number 20. In the MIPS architecture, does there exist an addressing mode that supports the register move operation? Yes, move operation. Move value from one register to another register, right? Yeah. So here, suppose this is R1, this is R2. Now we want to move value from R1 to R2. Yeah. Then addressing mode. So you can use one of the addressing modes in MIPS architecture to represent this register move operation. If you can do that, answer is yes. If you cannot, so you try, your best. If you cannot, then you may have a different answer. Yeah. All right, so number 21, in the instruction, this instruction. Yeah, so hope you know the meaning. Yeah. In our notes, I give you the specific meaning. Which of the following expression gives the result of this instruction? So you can see here, I do not talk about MIPS architecture, right? So in the statement, I didn't use MIPS architecture. So this instruction does not belong to MIPS architecture. So yeah. So then you try to represent the result of this instruction, addition result. After you do the calculation, you get the value of the result. Which one has that value? Okay. All right. So next one, number 22, in the instruction store R2, comma 80 parenthesis R1, which of the following expression gives the destination location? Destination location, right? That's the address. Location corresponds to memory address. Okay, yeah. So then, here, remember we use the displacement mode. So you use the displacement mode way to represent memory address. Yeah, pretty straightforward. Yeah, so you can get it easily. Yeah. Number 23, in the instruction, store R2, comma 44 parenthesis R1, but this time we need something different. Which of the following expression gives the value to be stored in memory? Okay, so here we don't look at the address part. We just want to look at the value to be stored in memory. So that part, yeah. So that's quite different, yeah. But also pretty easy, pretty straightforward, yeah. All right, so the last slide of this video part 3, question number 24. In the instruction, add R3, comma R2, comma at parenthesis R1. Here, I do not mention MIPS architecture, so we do not require it's a MIPS architecture. Yeah. What is the result value of this operation? Result value. See, we need the result value. Okay, addition. After do the addition, the value. Yeah. And especially, you need to know the meaning of that. At parenthesis R1. Okay, yeah. So in our notes, we have that part. Yeah. All right, so then the addition value. Yeah. All right, so the last question, number 25, in the MIPS architecture, among all the possible instructions, what is the maximum number of bits used to encode all the register locations for the operands? All the register locations for the operands. Maximum number of bits, yeah, because for different types of instructions, the number of bits used to encode register locations for the operands could be different, right? Could be different, yeah. So then you try to find the one with the maximum number of bits. Yeah, yeah. Also, pretty easy. Yeah, you can get it. Yeah. All right. So let me finish. Explanation of all the questions. Yeah. So the whole set of questions pretty straightforward. Not hard. So I believe you can do it well. Yeah. All right. So let me just stop here. Yeah.